All right, questions? Oh, very good. All right, so last time we talked about complex numbers, and then I wanted to start talking about equations, but we didn't have time to begin this. So the first thing that we did was we discussed a little bit about factoring. Okay, so some basic techniques of factoring, because that's a good tool to know when you want to solve an equation. So we did greatest common factor, we did trinomials with leading coefficient 1, and also we did an example when the leading coefficient is not equal to 1, okay, over here, and we discussed the AC method. And we stopped there, so let me do, I guess, one more example. Yeah, sorry, one more, so let's do one more example, and then let's discuss equations, okay? So the plan for today is we're going to talk about quadratic equations in general, then we're going to talk about equations that are quadratic in form, and radical equations, okay? So that's the job for today. All right, but for that, let's take it one step at a time. So I just want to continue exactly where we finished last time. So we did this example, let's do another one. So let's do 6x squared 17x plus 7. All right, so let's see, who can tell me how should we factor this? What do we need to do?
So by the AC method, 6 times 7 is 42.
Okay, so we look at 6 times 7, which is 42, yes?
Yeah, and then you need to find something, you need to find two numbers so that the product is equal to, between them is equal to 42, but their sum is 17.
Okay, good. So we need two numbers so that the product equals 42 and the sum equals 17. Okay. Anybody can think of the numbers? Yes?
14 and 3.
14 and 3. So let's see, certainly 14 plus 3 is 17, and then multiply with 12, 40. Good, 42. Everybody understand this? Now you have the two numbers. What do we do with this? What do we do?
You split the 17x into 14x and 3x.
Exactly. Remember, these numbers, they have the property that the sum is 17, which is the middle guy. So you split it, right? You write it as a sum. So this becomes, so the first and the last, don't touch them. Then the one in the middle, you write it as 14 plus 3. 14x plus 3x. And now, what do?
You group them.
We factor by grouping, right? And notice that here you have 4 terms. You can always group the first 2 and the last 2, okay? And it will always work. So I'm gonna group these two guys and these two. And to factor by grouping means that there may not be a common factor among everybody at once, but when you make groups, there will be a common factor between, inside those little groups. You factor that out, and then the idea is that something will be left over that's the same for both. Then you factor again, okay, like what we did here, right? So in groups, factor something, and then notice how an x plus 3 came up in both cases. Then you factor that. Okay. All right, good. So what's the GCF for the first group? 2x, good. And what's left when we take out 2x? So we're gonna have a 3x, yes? A 3x plus 7. And then the other one, there is no common factor, but notice that the 3x plus 7 is exactly what we're looking for, so it's fine, we'll just keep it like that. 3x plus 7. And remember that I'm putting parentheses to express the fact that, they look the same. And remember there's a 1 here, even though we don't write it, okay? So if you want to, you can write it. You don't have to. So now you can see that we have a common factor between those two terms, so we factor that again. So we take out 3x plus 7, and then what remains? 2x plus 1. Okay. Any questions? Do you understand this? Okay, good. Good. So again, this is the easy method. There is another one which is a trial and error, but that one is faster, but it's a little bit more involved. For example, I'll show you how I would do it. Because I typically don't use the easy method. I would do it using the trial and error. So basically, here is the term 6x squared, and here is 7. So what I do is I split 6x squared as two numbers here, as two expressions, whose product is 6x squared, and then two expressions here, whose product is 7, in such a way that when you cross multiply and you add, you get the middle guy. Okay? So you just have to start playing around. For example, you just start trying in your mind. Like if you do 6 and 1, that's not good. Why? Because then here, because this is 7, 7 and 1 are the only options, either 7 here and 1 here, or the other way around. 6 times 7 is too large. You get 42, there is no way you will be able to get this 7 feet. So the 7 better go here then. But when you put the 1, you're going to get 6 plus 7, 13. So you're off by 1. So this is not good. That's not a good choice. So what's the other possibility for 6? 2 and 3, right? So we're going to put I'm going to put the 2x here and the 3x over here. And we already know that this is 7 and 1, so we just figured out where to put it. If we put the 7 here, I'm going to get 21. That's too much, right? So I put it here, I'm going to get 14 with the 1. So you're done. So you put 7 here, the 1 here. You cross multiply, so that's 14x plus 3x. Again, this goes in your mind, okay? Typically, all of these analysis. And so the factors are 2x plus 1, 3x plus 7. Okay? That's it right. It's a trial and error. Some people like to write it like, they do this, and then they do this type of analysis by linear. I like to put it like this because I think visually it's easier to play around with the numbers if you have it in this form. Okay, but I will stick with this one. It's a little bit longer, but it's easy to understand. Okay? It's easy to understand. All right, so that's factoring trinomials. So let me remind you of another one, which is difference of squares. We kind of talked about this last time when we did product of conjugates of complex numbers, right? So factoring difference of squares. And remember, the formula is a squared minus b squared. What is this equal to? What is this?
A plus b times a minus b.
A plus b times a minus b. So every time that you have a difference of two perfect squares, you can factor it this way, okay? So let's do a couple of examples. So let's do x squared minus 64. And let's do 4x squared minus 25. So here the point is to identify what's A and what's B. And then once you recognize this, then you're good to go. All right. So how about the first one? Do you recognize that this is a difference of squares?
Yes.
Okay. So how do we factor this?
X minus a.
Very good. So in other words, you can think of this as x squared minus a squared, right? And then it's clear what's A and what's B. So this is x plus 8, x minus 8. Good. How about the next one? Do you recognize this as a difference of squares? Okay. What's your A and what is your B?
2x plus 5, 2x minus 5.
So you can think of this as 2x squared minus 5 squared, right? So that would be 2x plus 5 times 2x minus 5. A plus B times A minus B. A is 2x and your B is 5. Good. Any questions? No? Okay, perfect. So let me give you two more and then we start talking about equations. So how about this? So more examples. Again, factoring is something that we're going to be using very often. So I want to make sure that that we are okay with this. So how about this one? Okay, I'm going to give you a couple of minutes to factor these two expressions. And I want you to factor completely, as much as you can. Okay? course, I think it goes without saying, but to be able to factor successfully, you need to know all your times tables and so on, right? You need to be able to know this on demand, so you can figure out quickly what is it that you need, the pair of numbers, etc. So you don't, you should review those. Okay, let's see the first one. Anybody has an answer for this one? Yes?
3x minus 18 and x plus 1.
3x minus 18 and x plus 1. Now, is this completely factored? Remember, I asked for the complete factorization. So, in other words, can we factor something else in here?
Yes.
Yes, we can. What's going on here?
With 3, and then x minus 6.
We can take out a 3, right? So we can take out a 3, and then you have x minus 6, x plus 1. Yes? So here is an advice. Whenever you're going to factor, try to always look for a greatest common factor first. Why? It's going to make your life easier, okay? You're going to make your number smaller. But here, if you try to factor this, maybe using trial and error AC method, you will have to deal with, slightly bigger numbers that you really need to, okay? So notice that when you look at this, everybody's a multiple of 3. So you should factor that first. So you can take out a 3. Yes? You take out a 3, and now just focus on this one. We just need two numbers to plot the 6, and the sum is -5. What are those numbers?
Minus 3 and minus 2. Negative 3 and negative 2.
So we need -3 and -2. Good. So yes. So we have x minus 3, x minus 2. So that means that there is an issue here, right? There's a problem here. So let's see, where did you get this x plus 1 from?
I did x minus, wait, no, x squared minus 6 plus 1. Minus 6x plus 1x.
Minus, say that again?
X squared, I'm going to do it backwards. X squared plus
Oh,
x.
you mean you want to multiply this?
No, I don't
I'm just curious how you got this x plus 1. I mean, because it's not correct, right? I mean, let's multiply quickly. So you're going to get 3x squared plus 3x minus 18x minus 18, right? If you multiply the expression that you gave me. So this one right here is going to give you negative 15x, but then you have a negative 18. It's a positive 18, right? So if this would have been negative 18, then yes, this will be the correct factorization.
Yeah, I'm so confused right now.
So I'm just wondering, how did you arrive to x plus 1?
I have no idea.
Me neither, not in your
I
brain.
can tell you if I knew.
But just be careful. So again, my advice to you is factor. If you see a common factor, take it out first, because that's gonna make your problem easier. You're gonna make your numbers smaller, okay? And then you need to factor this. So again, if this would have been a -6, then what would have been the factorization? If this would have been a -6, then it would be -6 and +1, right? So maybe when you copy the problem, I imagine that instead of a plus, you put a minus here in the 18. And that's the reason why the x plus 1 was popping up. So what I'm saying is, if this would have been a -18, then the answer would have been 3 times, and then, what is it? X minus 6, x plus 1. Okay? That would have been the answer if this was a -18. Okay. Any questions on the first one? Good. How about the second one? Yes?
Is it x squared plus 4x squared minus 4?
Well, I asked to factor completely. Is that completely factored?
Actually, no. So x squared plus 4 and then x plus 2x minus 2
So x squared
plus 4
plus 4,
and then x plus 2x minus 2.
x plus 2x minus 2. Good. In other words, this right here is a difference of squares. You can recognize it, right? Because you can think of this as x squared squared minus 4 squared, okay? So the initial factorization using the formula would be x squared plus 4 x squared minus 4, but remember, you need to factor completely. So this one, we cannot factor this more over the reals. If you allow complex numbers, then yes, you can keep factoring this, but we're not talking about complex numbers at this point, right now. So, but this one we can keep factoring because it's a difference of squares, right? X squared minus 4. So you can break it up more, and it will give you the line below. Because this is x plus 2, x minus 2, right? So you get this. Good.